Who am I? You don't have to remember me. You can find me anywhere in the social medias. Not active that much, but yeah, it's about this today. I'm going to take you to a journey of AI developer. So where do you start? Where do you find information? How do you take the first steps? When you take the first steps, when you take the second steps, how do you take that? What kind of trade-offs do you make? And last but not least, evaluation and safety. How do you think about that? There's a lot of things in here, but let's see how fast we can go. First of all, the LLM, SLM life cycle. It's not linear. But to be very honest, I'm in the software industry for the last 20 years almost, and this picture is differently depicted for different technology. You always start with an ideation and exploring. Only the components are different here. You do try your prompts, you try to find out which LLM suits your use case better. Then you go on to building and augmenting. So for example, how do you do exception handling? Nothing new. Software development. How do you do evaluation, test-driven development, which is nothing new. But it's a little bit different in LLM, SLM world. What is new in that respect is the RAG, Retrieval Augmented Generation. To be honest, I'm not going to talk about that at all today. It's adding context to LLM when you are querying or letting the LLM do tasks on it. Lastly, but not least, is the deploying monitoring side, which is also quite similar. You have to deploy your application somehow. Things are a little bit different, but the core basics are pretty much similar or manageable the way you build software, to be honest. But there are a lot of things slows down the Gen AI adoption. And we in Microsoft, I work specifically with startups and scale-ups, and they are pretty forefront on this technology adoption, but not everybody is. So first of all, where do you start? There is a lot of resources available. If you do a search, you'll get 200 results. But where do you basically use and test your prompts? Free, to be honest, free. How do you get a developer key which you can build an application on top? Free. Then once you do that, then comes the part of I have an LLM, I have an API, or I have somehow a way to call these applications. How would I build an application on top of it? How do I write code? What should be my design patterns, to be honest? How do you provide context, the RAG part of it? How do you do evaluations? Is the test-driven approach applies here as well? What are the tools there? What do I need to take into account? Operationalizing, how am I going to deploy this? I'm going to scale this. What's the monitoring side of it? What are the different options for me for deploying such LLM or SLMs? First, I'm going to talk about how easily you can get started. How many of you know GitHub Marketplace? How many of you don't have a GitHub account? OK, this is a good crowd. So GitHub Marketplace has a model catalog, which you can use to find the models that you want. So let's say I'm going to search for O. If you click on there, you'll have a place to do the playground. Raj was showing you AI Foundry. For that, you need a subscription. Here, you just need a GitHub account. This is free. You go test your prompts as much as you want, and you can actually get a developer key, which has rate limits, but to build an application, to start an application, to think about how you use an orchestration model, how to use the API, how to write code in the language I like or the language you like, easier. Once you are done with that, you can actually move to AI Foundry. So that's the next step when you start paying for these tokens. But you know what's the best part of it? You can compare. So for example, I want to compare with 4.1. It opens up a window next to each other, and you can try the same prompt. You know, in my opinion, the hello world of LLM is summarize the document, which I'm not going to do today. I'm going to ask it to do something a little bit different. So I have 8 customer references or feedbacks, and I want to structure that in a JSON content, which is something similar to when you do an application. So you get an information, you structure that information, you send it to the next application. So I want to see how this prompt is going to perform on 4.0. Did I copy it? No, eh? I get to copy something else. How it's going to perform in both the models. What you can easily see, if given the infra remains the same for these two models, which one is faster? One. Second, you can see, given the instructions of my prompt, which model give me the results back that I wanted. In this scenario, if 4.1 is the new model and you want to move to 4.1, you might need to think about your latency increase. You might need to think about, maybe I need to provide a prompt which gives me back the JSON itself. If I'm not wrong, 4.1 gives you more than the JSON. The 4.0 gives you the JSON back. Something to think about. First thing. So, GitHub Marketplace. First step to find a model, try out your prompts, compare them. If there is a new model coming out, see how it performs. All the models that are available on GitHub Marketplace are also available on AI Foundry. And there are also open source models or open license models available on GitHub Marketplace as well. So once you've done that, so this was a GitHub Marketplace. So next thing, let's say you tried out a few prompts. You figured out I have 2 or 3 models which can be used in the use cases I have in my mind. How would you select a language model? This is an opinionated approach from my side, but these are the 4 pillars always I think about. Latency, tokens per minute, tokens per request, and cost. There are multiple other things also available. I'm not taking into account the functionality that you need for a language model, like image processing, text processing, or both together. But these are the trade-offs which you need to think of. So for example, if you want to go the tokens per request higher so that you can send multiple prompts, a larger prompt to the large language model or a small language model, or you get back a larger results back, your latency will go up. It'll be slow. So Gemini has the highest one right now, and if you use Gemini, it has a higher latency, to be honest. Do you need that? Do you want to process a larger amount of information per request? Yes, maybe a model which supports that is your choice, but in that case, your latency will go up. You have to think about how you manage those expectations when you're building those applications. Another thing is quite interesting, the tokens per minute, which is somewhat related to concurrency thinking. So if you have a use case where a lot of users are hitting your application, which uses large language model or small language model at the behind, so that means you're getting a lot of requests, which doesn't have to be larger, but you are processing much larger number of tokens per minute. And then your costs will go up. To be honest, the TPR has also an implication on cost, but these are the trade-offs you need to think about. So first, once you have a list of models which you want to work with, think of the trade-offs that you can deal with in your application. Once you have those 2 steps done, then comes the part, how would you deploy this? How do you envision using this model in production, or anywhere, to be honest? There are actually 3 ways. I'm going to talk about only 2. And time doesn't permit me to go in the demo, but I'll see. So first one is model as a service, which we are quite familiar with. You deploy something, and you get an API. You have an API key. You invoke the API with a JSON-based request, and you get something back, which is pretty easier to set up relatively. The access controls are access control which you are familiar with, an API-based application. It's basically a SaaS model, to be honest. You are using software as a service. It's mostly consumption-based, or you can also commit to consume, at least in Azure, in any other. The responsible AI part, which is a tricky one, mostly on you. Doesn't matter whether you go a containerized or not. But there's another use case, actually, which is containerized, and normally that's being positioned when you are fine-tuning a language model. But to be honest, you can also use that as a deployment option for your language model, which you're not fine-tuning. For example, Phi 3 model, to be honest, or Mistral. You want to run it on your own infra, where you have control over the scalability, latency, tokens per request, not tokens per minute, to be honest, token per minute. And then you can actually think about how am I going to scale up and scale down depending on the requests and information comes in, which is a little bit relatively complexer path, to be honest, because you need to maintain a registry, you need to maintain the Helm or the Kubernetes scripts, which you're going to use to deploy the model. But there are things for it. I mean, you need to also think about your model cost, the license cost, your pipeline cost, your Kubernetes costs as well. But let's take a step back and look at the model as a service. Model as a service also has two options, to be honest. I pay as you go, and you reserve something, a commit to consume. So you pay monthly or yearly based on how much you think you're going to consume tokens. You think, OK, model as a service, two options, correct. No. Another level deep, you also need to select one of these. Things get complicated here, because I was working with a startup who had a client in Switzerland, and they had a requirement that the model data processing and data residency should not go out of Switzerland. So we needed to select a model which we could host in Switzerland data centers. It couldn't go out. So first one was the region one. So you need to think about, when you're building an application, is my data processing and data residency should stay in the same region? Then either you choose pay-as-you-go or reserved. You need to think about the region-based deployment. Then comes the data zone. So if you're allowed to process your data across EU or across EUS, then you can select such data zone. So even though your model is deployed on, I don't know, Germany, but still the data can be processed across EU region. So then you get a little bit of load balancing of your calls, and it will be a little bit faster, to be honest, than the region-based deployment. Then comes the global, which is pretty similar to data zone, but globally. So even though you deploy on Germany, your data can be processed across the world. So maybe in Australia, there's a low load at this point of time. Your request can go there. So two things you need to remember for the first three: data residency and data processing. Wherever you're hosting your model, your data stays there. The logging happens there, but the processing happens somewhere else, depending on what you choose. The last two is basically for the async use cases. So if you have a batch type of a job needs to be done using a language model, you can either select a batch deployment or a global batch. So batch will stay in a region, and the global batch will globally load balance. But actually, I come from a Kubernetes background and Java. So I like to have my stuff managed the way I manage my microservices. So if I have a Kubernetes cluster or multiple cluster where I deploy my microservices, I want to manage my large language or small language model also within my Kubernetes cluster. How would you do that? How would you make sure which GPU you need, how much memory you need, how much, what should be the scaling, what should be your deployment configuration would look like? There comes an open source project from Microsoft called Kubernetes AI Toolchain Operator, Kaito. This is right now for AKS, but they are going to use it for other distribution of Kubernetes as well. What does it do? It streamlines your deployment process. It takes over the load of provisioning the VMs that you need, managing the GPU loads that you need, and does it for yourself. Now, what you need to do, create a custom resource definition. And that looks like pretty similar to like this. So if you have a Falcon B model which you want to deploy, you only mention the instance type of the VM that you want to do. The rest will be taken care of by the toolchain operator itself. It'll create a separate node pool, it'll instantiate the VMs that you need, and it'll tell you how to do stuff, to be honest. So for example, I have a cluster, aka Skyto, which I have a custom resource. This custom resource actually have custom resources running on Kaito script on the behind. So you enable this functionality on AKS cluster. And it's not available on AKS managed yet, but it is available on AKS traditional. And you get this, you can deploy your workloads or your containers, language model containers within this place. So for example, I have deployed a Phi3 mini in my AKS cluster. And inspired by the first presentation of having Chuck Norris jokes, I thought, why not ask it a Chuck Norris joke? It'll deploy it, it will show you anyway. But the point is, you now actually consuming the large language model within your Kubernetes cluster just as an API, like a microservice, which you are normally would do for an application development side. Fast, fast, fast. What I'm going to show you is the project as well. So if you go there on their GitHub, they have a lot of examples on fine-tuning and inference. So I picked up Phi3 from this inference. Wow. You'll see the YAML. You'll figure it out, actually, to be honest. Now that you figured out how you're going to deploy a new model, what are your trade-offs, what the model is in your thing, your friend comes in, your colleague comes in and say, hey, have you heard O3 is released? What are we going to do about that? How are we going to onboard a new model? This space is so fast evolving. If you don't have a strategy on how you onboard new models, you will be lagging behind. And that's one of the reasons also we see in the enterprise client side, they are hesitant. They are looking for design patterns. But to be honest, you don't need to look for design patterns. It's already there. We have a lot of abstractions available in software industry which we can take advantage of looking at this ever-evolving space. So we have right now 1,864 models. This was from last week's screenshot. I think it's more than 2,000 right now. And how would you manage? So new model is a nice approach, but how do you manage tokens per teams? How would you manage, how do you make sure that one of the team doesn't exhaust all your tokens that you have paid for this month? How do you build your client? So I work with startups. There, the major question is, if I'm going to release an AI feature, how am I going to price this? If they choose for pay-as-you-go, how would I know how much they use? We have a problem, but actually not. API management. I'm not asking you to use Azure API Management. I'm asking you to think of an abstraction layer. Azure API Management will give you the features of doing all this stuff. Pick up an abstraction layer which will give you those stuff as well. So for example, how do you limit token? So if you have a month token limit, you want to request per request, you want to have a limit to reach as well. How do you make sure you log that? How do you get the information back that Soham used, I don't know, 1,000 tokens today, so he needs to be charged X amount of money at the end of the day? How do you make sure you do circuit breaking? So if your zone 1 is going to die, how do you switch back to zone 2? How do you do semantic caching? How do you manage your identities who are connecting to it? So a lot more features are there in API management. So take a step further. So when you have your model, you did your trade-offs, you find out your deployment model, think about how you abstract that. How would you keep your pace as fast as possible with the evaluation or the things that are the change that are happening in this industry. How many of you know Azure App Templates? 2, 3, okay? You know what I say always when I try to speak? I say, you are spending time, I'm spending time, I have to give something you back. Thank you. So this is something I give you back to the -3 people who are sitting in this. So Azure App Templates, if you go search for Azure App Templates, you'll land up in the GitHub page. Why am I showing you this? Again, model, trade-offs, deployment options, abstraction. Now you want to build your applications, and you want to know how these applications can be built. What are the different components I need? Do I need microservice architecture? What kind of evaluation should I do? Where are my bicep templates of Terraform, to be honest? How would I code in Java? Or how do I build this in Python? How do I build this in Node.js? Azure App Templates have right now 43 different templates. I am a Java guy, which is very evident from my shirt. So I'm going to pick up a Java example. This is written in semantic kernel. Edward, can you hear me? What does it do? It is a basic agent implementation using an orchestrator pattern. So there is an agent router sits in the front, and it decides, depending on the incoming request, which agent I should route this to. And that agent will pick up an backend API to call it. Very simple implementation, but tells you if you have an orchestrator design pattern, how do you implement this in Java? What do you need besides writing code? Do I need container apps or AKS? Do I need an Azure monitor? How am I going to connect this? Do I need OpenAI service? Do I need blob storage? I'm not sure how many of you have CLI access. If you don't, you can also go to the GitHub repo, which is free, and check out the whole code and how it is being done. One of the examples that I like, 8 minutes. How much do I? Okay, that's good. Can be possible. Resource groups. One of the examples there is the creative writer. I'm not sure whether you've seen this. If you've seen this, I'm going to show you again. Why do I like this example? Because this kind of portrays how an agentic application would look like. So this is an example of to write an article. And at the back, there are 3 different agents working to create this article. So if I just pick an example of, I don't know, slipping back in tense, it'll start working. And the first agent will pick up this task, do some research, pass it on to the next agent, and the next agent will do its job, pass it on to the last agent, and combining all of this, the writer agent will create this article. Now, given the fact of how indeterministic this application is, the next question your product owner or architect will ask, how am I going to test this? If I change something in the code, what is your plan or strategy to test that? How do you track it? If I introduce a new model, how am I going to manage that? Good question. All good questions. So I actually forked this repository quite a while ago. And the best part is, some of them comes with workflows. So you also have an idea how do you structure these applications. So there's a lot beyond coding which you need to take care of when you're building an application. Doesn't matter whether it uses large language model, small language model, or no language model at all. So the point I'm trying to convey is, if you are in a point when you want to write applications, check out this Azure App Templates where you have a lot of examples on how would you structure that. So if you have in your landscape already container apps or AKS, look for those application-specific example. If you are fond of a specific programming language like me, look for such applications, because then you also get to know which all tools are available, which all SDKs are available for you. And for example, this evaluation, which I ran quite a while ago, as the commit message says, stressing on, it also went to the log analytics, which I'm going to show you later on in Azure. But you want to run such kind of reports when you do change on your code, so which will automatically not only give you a report back, but also do the tracing back to your whichever log or monitoring platform you're using. Five minutes, OK. Azure App Templates. I talked about that. I talked about also this, which is basically the architecture of the Contoso Creative Agent, which is also there in App Templates if you look for it. Last but not least, evaluation and telemetry. Raj talked about content safety. I'm going to also talk about content safety. but I'm going to talk about in a very code-specific way. So, how many of you know this repository, the big prompt? This is a collection of jailbreak prompts. So I picked up the 4.0. I am not being compliant here. I have to tell this because I'm on camera. This is not what you're supposed to do. The point I'm going to make about content safety is required for me to do this, but this is not what you should do. I am not going to explain what I'm going to doing. I hope you are. Where is my? Here. So I go back. I clear my chat. I put this, and I get a recipe back of something. I'm not going to tell you what, but I'm going to get a recipe about something. You don't want that. I mean, Raj also made it very clear, you don't want that. But how do you stop it? How do you stop it? Blocked list is one of the good examples which you said. But since I'm a Java guy, I have to show you some Java code. I cannot go out. Who am I? Who are in Java here? Yes, good. Okay, this is bad. So what I did is I created a small application which invokes my LLM. What I injected is content safety. Content safety is a resource within Azure which you can create. You'll get an endpoint and a key back. The way you manage your resources in Azure, that's up to you. But you get that API back. What you can do is create an application which intercepts all the calls going in and going out from your application using LLM. So the first thing I'm doing is, because I'm very good at testing, I am actually testing input and output validation. So it is the same prompt, but I actually test it with input validation and output validation. And I have 2 minutes left, thanks to God. So on the first test, it blocks the input itself. So you basically stop it to execute anything to LLM, which saves you money, definitely, but it also saves you reputation from being on the first page or the front page of anything. You can also switch on to actually do the output, and the output will basically generate the response, but it'll stop you to give you back anything. So you see it generated a response, but I didn't get anything back because it is flagged that output is not safe. This is interesting because the way it is evolving, this platform, this technology, you also need something which you can actually hook to your applications or your calls to check whether this is safe to execute or safe to return back or not. This is one example. He has also mentioned about prompt injection. So how many of you know the story of a guy made sure that he bought a car in $1 and it was bounded by injection, prompt injection. So I have a prompt injection example, which is using Dan, so do anything now. So I instruct it to do anything now, and it'll gonna stop me to do it. So content safety also has a preview feature of content shielding, so prompt shielding. And it'll shield my prompt. I'm not gonna run the test because I do not have much time. But with the SDK, you have not all the features available for content safety. This is my knowledge until yesterday. Maybe today it's going to change. There are a couple of preview features which you can only access by API. You can generate client classes with this API definition. And then you can do all sorts of things, blocking stuff that you do not want it to be generating, shielding the prompt so that nobody can buy a car with $1, for example, or stop giving back a recipe that you are not really want to do when you do not want to get into the front page of a newspaper. So yeah, this is kind of the architecture that you should look like, as in putting Azure Content Safety as an interceptor between your applications and the LLM calls and filter out things that you do not want to do. Evaluation, on the other hand, Azure as Foundry SDK claims to add 2 lines of code to have your monitoring and logging done. But to be honest, you also need to do a little bit of config. So to be very honest, 2 lines of code is right, but you also need to do a bit of a config to make sure you can add it to any orchestrator framework that you're using. So semantic kernel, AutoGen, LangChain, Llama, doesn't really matter. And it looks like this. So since I don't have time, so the Azure AI Foundry actually gives you a logging tracing page where you can see all the calls happen to Azure AI Foundry, so all the LLMs. So it will basically do the post calls, show you what's happening. And that's a KQL actually on your log analytics workspace. And you can also see the server request, server response, and et cetera, et cetera. I showed you this a little bit before the evaluation. So I started with a very negative sentiment of what slows you down, right? So I want to give you, before you go to food, what boosts your AI journey? So first of all, how do you get started? Start on GitHub Marketplace, free for everybody has a GitHub account. It's free to get a developer key. Start there. Compare your models. Understand what are the trade-offs. Understand if there's a new model come out, can I use the same prompt that I was using for all my older application? Development, you have Azure AI Foundry, of course, but you also have the development key to use when you're building an application. Context, use RAG. I haven't talked about it, but you can find enough resources in the internet about RAG. Testing and monitoring, which is a very interesting and important step before you start. So as a developer, you also need to think about if I'm producing this code, how I'm going to test it. What is my application structure would look like? Look at app templates, look at the biceps, look at the testing script, look at the GitHub workflows, how they are configured. And lastly, think about your operationalization, so model as a service, or deploy as a container, or deploy as a VM, which I haven't talked about, but you can also host it in a VM, to be honest. There is Kaito to help you to do it on Kubernetes, which, in my opinion, most favorable way if you want to scale higher than what you expect right now. So with that, I would say thank you for listening to me. I am around, so if you have questions, feel free to ask. I don't have all the answers, but I'll try. Thanks.